first we're going to have Xinyao from Airbnb is going to come up. He's the engineering manager in core storage at Airbnb. There he manages all the online storage services, including MySQL and Redis, among others. Before that, he worked as an engineering manager in newsfeed backend at Facebook. Newsfeed storage is one of the largest distributed RocksDB deployments at Facebook. So welcome, Xinyao.
Hello. So this is Xinyao speaking. I'm an engineering manager working in Airbnb. So for those of you who don't know Airbnb is an online marketplace for hosts and guests to meet. So we provide lots of different listings, and in order to bring the very unique experiences to you. So today I'm going to talk about Spinaltap. So Spinaltap is Airbnb's data changer capture system. So before we go into the detail of Spinaltap, we want to give you an overview of the architectures of Airbnb. So Airbnb starts from a very simple Ruby on Rails applications. So it's pretty much, initially it's pretty much one web boxes plus a MySQL databases. Over the years, we have been evolving our architecture to a more service-oriented architecture. This is a simplified version of our infrastructure. So it looks like 4 different layers. So on the top layer, we have Clara, which is our request routing layer. Then we route a request to Monorail, which is our web layer. This is a Ruby on Rails stack. Then those Monorail layers forwarding the request to a bunch of service layer. This is a lot of those services was written in Java. So basically, we have search written in Lucene. Pricing is our heavily used a lot of machine learning algorithm. Then we have risk and booking and payments in those. And these monorail boxes and those Java services and talking to a set of different databases. We have like calendar messaging and one of the most important databases for us like Airmaster. And we're using MySQL as databases and we're using asynchronous replications. So over the years of moving, changing a single Ruby on Rails application to the service-oriented architecture, we have some basic design principles. For instance, we want to making sure we always build it for production. We always anticipate the load will increase, and we always favor existing mature solution like MySQL. And also, there are 2 very important design principles which like leads the motivations of Spinaltap. One is that we want to make sure service on its own data, which means that there's no 2 different services going to talking to the same databases. Because we want this type of separation, each service is talking to its own databases. We need to have a way. For services communicating the data changes. So data changes are going to populate through standardizing events. So this leads the motivations of a change data capture system. So there are a bunch of different requirements of the change data capture system. For instance, we want to making sure it's timeline consistency, which means that the ordering of changes of a single row cannot be reversed. And also, we want this change data capture system to be near real time, like very fast, very low latency, and want to making sure that we never misses or sends the wrong data into the data change capture system. So this leads the overall architecture of Spinaltap. It's our data change capture system. So we have a bunch of services going to does writes to different type of data stores. So in this case, is that we're using both MySQL and DynamoDB. And Spinaltap as a services is going to listen to the changes to these databases. It's going to populate the changes into Kafka in a very neutral format. The reason we're using a neutral format like JSON is because we don't want the downstream services to enter the specific of MySQL replication protocols. Then once the changes lands into Kafka, we have a bunch of different Kafka consumers consume these messages and doing its work. And also we write the data directly into HBase so that our data warehouse can consume it if necessary. In addition, recently we have been investing a lot into streaming. So we had a bunch of streaming jobs reading the Spinaltap messages in Kafka, does asynchronous processing, and then writes into Kafka again for more processing. So the requirements of Spinaltap is that because we're using Kafka, so we ensure at least once delivery. And also due to the requirement that we had hundreds of MySQL instances, we want to make sure that whenever a new database pop up, it's very easy to add a new data sources. And also, we want to support very high throughput and low latency use cases. Oftentimes, we need to run some kind of one-off jobs going to does writes to every single user. That's on the order of hundreds of millions of rows. And we want to make sure that during this type of operation happens, there's no impact on the availability of the Spinaltap set. We want to make sure it's always a high availability, and we want to make sure that we can support new type of data sources in the future. So we're using MySQL and DynamoDB now. It is very likely we're going to support like Redis and other type of persistent store future. So how do we implement Spinaltap for MySQL? That we use, we're basically making Spinaltap to be a replica, listen to a master with role-based replications. And we'll be interested in these type of events, write rows, update rows, and delete rows. And we're using bin log offset or GTID as a logical order. And we've been attached these logical orders in the messages to the downstreams. And we're using XID events to separate the transaction boundary. So what type of use cases Spinaltap is powering? Spinaltap is powering a lot of use cases which we do replications across in different type of data source. A typical example would be it powers Airbnb search. So we build Airbnb search using open source software Lucene. So in this case is that there is a Kafka consumer reads. So the use cases that we want to power is that when a user changes the availability or the pricing of a listing, and our search indices is going to be notified immediately. So this pricing and availability information is persistent in MySQL. So we had a Spinaltap consumer reading from the listing tables and does the writes into Lucene so that we can ensure that Lucene and MySQL are eventually consistent. And also, we have a lot of use cases internally using Elasticsearch. We're using Elasticsearch for geological-based query or full-text search query. So in this case is that we using Spinaltap to ensure the eventual consistency between MySQL and Elasticsearch. And of course, we use it for mem caching validations. In this case is that we had a lot of different caching strategies. We do caching validations or we do write-through caches. So next slide. So for the offline processing, so being able to streaming MySQL bin log into Kafka made it possible for us to do more stream processing in Hadoop world. So it's a very big topic. I'm going to cover very small use cases here. So in this case is that we want to power MySQL point-in-time recovery into HDFS. Before, what we've been doing is that we had a cron job where we did a selected star on MySQL table and insert them into Hive. So the problem with that is we have databases with a couple of terabytes data every day. It does a selected star and dump into Hadoop. It's going to be very slow. So we've been using Spinaltap to sync all the bin log changes into HBase. So in this case is that we ensure the strong eventual consistency between HBase and databases. Once the data is living in HBase, every day we're going to take a snapshot of HBase and dump the data into HDFS. So this is faster than before because we can ensure like more parallelism happens in HBase when dumping data into HDFS. And also with a query layer of Spark, Hive and Presto and Spark, both of them understand the data layout in HBase and HDFS. So the same Hive query before can only work on the data which is like 1 day old. Now this Hive query can work on the real-time data. So now this is Spinaltap actually enables the possibility of us to do like more stream processing in Hadoop world. So that's it. Yeah, thank you very much. Yeah.